We're going to talk about the engineering design process and associated skills that we are using in science in Ontario, but also it is something I will be using in my grade 9 class throughout this semester. So when you think of the engineering design process, the idea here is that there's a problem that we've noticed in the environment. And then from that problem, we say, let's see if we can find a solution. And then once you have a solution, or you think you have a solution, if you look here, so you have a problem. Oops, let's see if I can make this bigger for you. There we go. So we have a problem that we see and understand. So initiating the process, then we are looking for ideas to solve that problem. So looking for solutions. So that's part of the planning. But once it is done, then we actually need to create our first prototype. So as engineers, we are using prototypes to answer a question, to solve a problem. So that's performing here the creation of it. And then we need to test our prototypes and then record some information. And in a moment, we'll have a quick look at how this works. And then the next one here, we need to evaluate and revise our prototype based on the results we have. And then when it's done, then we communicate the solution. Interestingly enough, as you can see, there's an arrow up here. That means that once you communicate your findings from your prototype, you can actually continue the cycle a second time to create a second prototype, a version 2 that works much better. This morning in my live, I was talking about the Boeing's project called the Starliner. It's sent in June 5th, 2024, the Starliner to the space station. That was amazing. That was the third capsule, the third version with astronauts inside going to the space station. And it worked nicely. However, they noticed that once they were there, the capsule had a helium leak and also had some difficulties with the boosters. So therefore, they had to see, okay, we have some problems. What will be the next step? First of all, to come back to Earth, but also we can create a better version or a better rocket, a better capsule the next time. So it's part of a large project, but it's an example on how this engineering design can work. So let's take a moment to look at all of these sections here to learn from it. So the first section here is about initiating and planning. So here we need to figure out, let's do some research and understand the problem that we are facing. So first of all, we need to identify the resources that are available about the problem. So that's something that is quite important, because if we are on Earth or on the ocean or in space, the environments are dictating different solution from different problems. So when it is done, we also need to figure out, okay, what are the users or who is affected by that problem? Keeping in mind that if there's only one person out of a billion people, let's say, if there's a person out of 8 billion people that are affected, the problem is not as big as if you're looking for drinking water where millions of people are affected. So that's something to look into. You may want to interview people, talk to people, gather data to figure out what is happening. And something interesting, you need to use some empathy, because sometimes when you see a problem or you see people that have difficulties, you have to be mindful that as humans, if they are in the problem, they may be in a survival state, and therefore you need to be there to approach the problem and be mindful of the humans and even help them or have them help you solve the problems. That's quite nice. Then what it is, you outline or you brainstorm some solutions, and then from there, when you have several solutions, then you go to the next part, which is ideate in general and generate potential solutions. So if you look at the problem here, we research a project, and then here we need to do the brainstorming. So let's see, what do we have here? So here we need to brainstorm several ideas. So here, different companies have think tanks. They are looking for as many ideas as possible to solve the problem. The big issue, though, is that you need to do some research. You need to look, has there been other problems like this in the past? Has there been solution proposed? That's something to look into. What are the success criteria, or what are we trying to solve, and what is the outcome we want? But are there um, any constraint, like with respect to space, with respect to time, with respect to resources and money? All kind of things to keep in mind. And then when it's done, we need to develop new solution possibly, or take all the different solution you have and then come up with what you think will be your best options. From there, you will be able to go to performing and recording. So here, there we go. First of all, we need to select an option to be able to solve the problem. Because if you just do the planning, the problem still exists. So you select an option and then you need to develop a prototype. Sometimes it may be a piece of equipment that already exists, but you want to make it better. You want to make it an improvement. So an improved prototypes. From there, you will be looking at the solution you've chosen, but you also have to look at the materials available. You need to look at the equipment available and sometimes the time available. I know that we went to some asteroid, for example, asteroid Bennu, and we brought back asteroid materials. But only 25% of the materials has been given to scientists and 75% has been kept in a vault. The reason for that is that we know that in 50 years, researchers with new materials, new equipment will be able to do research different than what we can do right now. So scientists can plan long-term doing that. For the same reason, we are doing research on moon rocks right now that were brought back from the moon in the 1960s and 70s. Now, you also have to keep in mind that you need to look at different aspects. The economical aspect, you need to think of the environment to make sure things are good. Is it ethical? That's something to keep in mind. With respect to ethics, you also have to look at the people involved, but also different communities, First Nations that may be in the area where you want to work. You also need to look at the health of the community in the environment and the safety, but also the health and safety of the workers that will be working with that solution. And when it's done, you create your prototype. Outstanding, we are creating something to solve the problem. But when it's done, we just don't want to put it on the shelf. We actually want to test that solution. You need to test it because you have a problem. You want to test your prototype saying, okay, is it actually solving the problem? And that's what we're looking for. So here you look at your different variables, you look at the context, and then you look at the observations from those tests. You're gathering data to see if it's working or not. Keeping in mind that you also want to look at the feedback from as many people as possible in the context of the project. In a classroom, that includes teachers, classmates, friends, family members, or community members. If you are in the engineering profession, then it becomes team members or company members or different, the research community indeed. Now, we have a prototype, we got some data. What do we have to do from here? We have to analyze and interpret the data. That's important because if you have data but you do nothing with it, then it's wasted resources. So here you analyze your results to determine if you actually were able to solve the problem or part of the problem. And when it's done, then it allows you to say, okay, let's see if I can review the initial resources that I used, existing knowledge, but also the new knowledge that I've learned. And let's see if I can find ideas to improve my design. Because the whole idea here is that you want to test your prototype. So the next one that you do, the version 2, version 3, or version 4 are actually much better. Very good. And that will allow you to say, okay, if I were to refine my prototype for the next version, here is what I would do. And that brings us to the communication piece. You need to be able to communicate the solution. So if you have people doing research, you're an inventor creating something new. But if you're not out there sharing your knowledge, sharing your discoveries, your discovery will not be known, and then you won't be able to solve the problem. So here you need to choose the type of communication you want to do. Nowadays, a lot of people are using social media to share what they do. For example, there's a company in Canada called Edison Motors. I've been following them for the last 2 or 3 years. They are putting together electric trucks for hauling, being merchandise, for example, in the forestry industry and otherwise. It's a company, it's a person who wanted to do their own trucks, and he's using social media to communicate his journey, but also his discovery. I know he put together the first truck, I think it's last year, and there's a lineup of people that are waiting, that have purchased a truck for him, and they're just waiting for the next version. So it's exciting. And then we need to identify the important information, because you need to have the information, but at some point you'll have to also create the instructions and all the information needed to make it work or to recreate that. Indeed, you review your plans, and then you make sure that your audience is great, and then you present your information. Science is amazing. A lot of people are doing science on their own. However, if you are keeping it to yourself and not sharing it to others, our society cannot grow, and therefore it's something to keep in mind. On this is the last step of, we are here, the last step of the engineering design. Let's see if I can put it this way. Perfect. Now, keeping in mind that if I'm here at the communication section, as you can see, there's an arrow here. And the reason for that is once you communicate your findings, you communicate what could be done for the next version of your prototype, then you come into, you can make it a whole cycle again. You have here a problem that is still there. You had a chance to test your prototype. You generate new ideas. Then you select new options to create the new version of your prototype. You test it, you evaluate, communicate, and that is a big cycle like this. And that's all part on how we can improve our world. That's why we need engineers, we need inventors, and we can do that in school, in the tech shop, as an inventor, doing coding, programming, or in the science class. This is all part of the fun things. Very nice. So if you have enjoyed this video, please, or if you have any comments, please put a comment below. Otherwise, I'm going to put here another link. Let's see if I can do this one this way. I'm going to put here another link to another video I've done where we're going to learn something new.